to another video of Physics Basics. In today's video, we're going to be discussing and doing algebraic review. As you know, physics, on-level physics is algebraic based, and all year we're going to be dealing with manipulating equations and rearranging variables in order to find our answers. So just like the conversions video and the skill set for needing to do proper conversions, the algebra skills that you need are going to be essential all year long. Hopefully this video will serve as a resource. Please feel free to come back to it as many times as you need. And we're going to go ahead and get started. Now, I know some of you are looking at the first few and you're like, wow, this is easy. Keep in mind that the equations pick up in range of difficulty, and it's not always going to be as simple as 3 different variables or just a simple multiplication or division. So let's go ahead and get started. One thing I like to address is also from previous years, I noticed that students get nervous when all they see is variables and they say that I can't solve for anything if I don't have numerical values behind it. Solving for an equation or a variable, you do not need any numerical values. The principle is the same. So whether it's with numbers or without numbers, the principle and the method of working them is the same way. So we're going to focus on getting your skill set up to par, and hopefully by the end of this video, you will be more confident in your abilities to succeed in this class. So the very first thing that you may see is this little triangle, and that triangle means delta. So that triangle delta essentially means change in. So we read this as change in. So the delta is change in distance over change in time. We're talking about velocity. Velocity, of course, is a numerical speed with a direction. And in physics, we are always concerned about direction. So delta is simply the change in. All right, so we want to go ahead and solve for delta D, or change in distance or displacement in this variable, in this equation. Delta D is currently being divided by delta T. And in order to isolate delta D on its own, you have to do what is being done to it, but the exact opposite. Currently, it's being divided by delta T. The opposite of division is multiplication. So we are going to be multiplying by delta T, which you do to one side, do to the other. And then these two will cancel out. Divided by delta T, multiplied by delta T cancels out. And go ahead and proceed with rewriting your equation the same way that you see it. So delta T times V is equal to delta D. And now we look at, is delta D on its own? Yes, it is. And we are done with this equation. We have isolated delta D on its own. So delta D is equal to delta T times V. And as always, go ahead and box your answers. All right, this was a one-step process, but as you go with the additional equations down the line and throughout the year, just please go ahead and rewrite everything step by step. And by that, I mean, when you cross something out and you have to rewrite the equation, don't try to skip steps because it only increases your chance of making errors. Just rewrite it the same way that you see, and it prevents you from making tiny mistakes. All right, number 2. Acceleration is equal to change in velocity over change in time, or delta V over delta T. This equation is set up in a very similar way to this. It's actually set up the same exact way. The variables have changed, and now we're solving for something that's on the bottom, delta T. So when you have an equation like this, there's a shortcut method that you can use, and it's very easy to use. It works 100% of the time as long as you use it in the correct scenario. And by that, I mean, it has to be for when you're solving for something at the bottom. Notice in the previous equation, I did not talk about any kind of shortcuts. So, because we were solving for the one that was on top. So in this case, it always works if it's for something that you're solving for on the bottom. The other scenario, or in the same scenario that it has to work in, is that it has to be a 3-part equation. And by that, I mean 1, 2, and 3. Not variables, because technically this is a 3-part equation as well. Here's 1, 2, 3, and we've got multiple variables over here. So it doesn't depend on the number of variables. It just depends on, is it set up in the same way, and are you solving for something that's on the bottom? So here goes a shortcut. All you have to do is draw a two-sided arrow, and anyone looking at this will realize that you got to flip these. So that's what we're going to do. Rewrite it as delta t is equal to delta v over a. And we look at our equation, delta d is on its own, and we are done. So there is your answer. Delta t is equal to change in velocity over change in acceleration. So again, this shortcut will only work if you're solving for something on the bottom. The variable has to be on the bottom that you're solving for. It also has to be a three-part equation, meaning one part here, one part on top, and one part on bottom. Now, I'm going to go ahead and show you the proper math steps behind doing this, and you'll see that we'll end up in the same way. Again, my shortcut, if you just draw these two double-sided arrows, I will consider that as work, and I'll be happy with that. I'm going to go ahead and rewrite the original equation, which was acceleration is equal to change in velocity over change in time. And now we're going to do the proper math steps. So first things first, delta v is being divided by, and when you have delta v being divided by delta t, you want to go ahead and do the exact opposite. And since this is on the bottom, you want to go ahead and multiply by delta t first. So multiply delta t on one side, multiply by delta t on the other. These two cancel out. And now go ahead and rewrite your equation the way that you see it. So delta t times a is equal to delta v. We're not done yet because we only isolated delta v when we wanted delta t. So now we look at what we have, and in this scenario, we've got delta t times a. These two are being multiplied. Do the opposite, which is to divide. So we're going to go ahead and divide by a. Do that on both sides. These cross out. And now we rewrite our equation as delta t is equal to delta v over a. Notice that we still end up at the same answer choice because this was a full, long, proper mathematical way of doing it. However, the shortcut is essentially the same thing, and the shortcut will work just as good. So again, if you just draw the double-sided arrows and you tell me that you know what's happening around here, that's considered work for my class. So delta t is equal to delta v over a. Now, on this one, we have a slightly different variation, and I wanted to point this out because, like I said, you got to have, if you want to check to see if your shortcut method works, first thing first is you got to check, is it for the variable on the bottom? In this case, we have b, and we have b squared. So technically, yes, and I say technically because there's an additional step, but b is part of the bottom part of this equation. Next part is it set up the same way? Do we have three parts? 1, 2, and 3. Yes, we do. Now, we've got multiple variables over here, x, y, and z, so we actually have 3 variables on top, whereas previously we had 1. That doesn't make a difference, as long as you are solving for the 1 on the bottom. So in the same token, we're going to go ahead and draw our double-sided arrow. We're going to rewrite the equation. B squared is equal to x, y, z over w. But we're not done because it's b that we're after, and we've got b squared. So you're going to have to take the opposite of it, which is the square root. If you do one side, you square root the other side as well. So now, the b squared with the square root gets canceled out. So all you're left with is b. So b is equal to the square root of x, y, z over w. Now, if you're punching in the calculator and you have the simple TI-30s, what I recommend is that obviously this whole thing needs to be square rooted, but x, y, z needs to be taken care of first, and this process needs to be taken care of first before it's square rooted. So you'll see that when you have mathematical problems with numbers, but you want to make sure that the top portion is multiplied, then it is divided, and then finally you take the square root of the whole thing. All right, so we are good and done with that one. Okay, so now we are getting some additional variables, and they are no longer set up the same way. Now these are in one horizontal line, but some of these may look alike, but there's tiny differences. So we have VF and VI. These are little subscripts, and subscripts help you identify what you are talking about. In this case, this stands for final velocity, and this is initial velocity. So this is what you started with, and this is what you ended with, as far as your numerical speed with the direction is concerned. Again, velocity is simply a numerical speed with a given direction. So final velocity is equal to initial velocity plus acceleration times time, and we are solving for time. The common mistake is that kids want to go ahead and get rid of the A as soon as possible. Worry about that later. For right now, we've got VI plus AT. So the first thing that we can go ahead and do the opposite of is subtracting VI. So we're going to go ahead and subtract VI on both sides. These two cancel out. We rewrite it as final velocity minus initial velocity is equal to acceleration times time. Since we want to go ahead and solve for t, these two are being multiplied. So you go ahead and divide by a. And remember, always do it to one side, do it to the other as well. Those two cancel out. Now we're going to go ahead and rewrite our equation. T is equal to final velocity minus initial velocity over acceleration. T is on its own, everything's done over here, and we are good. So VF minus VI over A. All right, number 4. This one uses similar variables. To some extent, we don't have T, so we have to use different variables in order to find whatever we're going to be solving for. In this case, we're solving for VI, and we have square root of both of these. So again, nothing too difficult, same process, just take the one step at a time. VI squared plus 2AD. So currently we're adding 2AD to this VI squared, and we're solving for VI. Go ahead and get rid of the 2AD by subtracting it. I know these are all being multiplied, but this is one complete set of variables. So we can go ahead and subtract all of that at once. So we're going to subtract 2AD on both sides. We're going to cross these out. We're going to rewrite our equation as VF squared minus 2AD is equal to VI squared. The problem wants us to do VI on its own, so you have to take the square root of that, as well as the square root of this. So when you take the square root, these two cancel out, so the square root and the square cancel out, and what you are left with is VI is equal to the square root of VF squared minus 2AD. Now keep in mind that this needs to be taken care of first before it is actually square rooted. So this whole process will need to be solved when you have numerical values, and then you take the square root of everything. But as long as you punch it in your calculator this way, it will take care of everything for you, so no worries there. And that's our answer. VI is equal to the square root of the VF squared minus 2AD, and you are done with that. All right, now we're going to go ahead and go to the back page of this algebraic review sheet. So now we're dealing with the same exact equation. VF squared is equal to VI squared plus 2AD, except now we are solving for A. And A is being multiplied by both 2 and D. And keep in mind, you can rewrite 2AD in multiple ways, one of which could be 2AD. You could also write it as 2DA if you wanted to. So for example, plus 2DA is the same thing as plus 2AD. And you could rewrite multiple different ways of this as well. You could say plus AD2 or plus DA2. When they're being multiplied, it doesn't matter what order they come in. All right. So just so we're not confused, I'm going to rewrite that same equation on top. This was VF squared is equal to VI squared plus 2DA. So these two are the same exact equations. Okay, so we're going to solve for a in this case, and currently a is being multiplied, but we're going to get to that last. Again, just like previous time, go ahead and subtract what you can, which is vi squared plus 2ad. This is being added to subtract the vi squared. Do it on both sides. Rewrite your equation, and that becomes vf squared minus vi squared is equal to 2ad. Now a is being multiplied on both sides by 2 and d. Remember, we said it's the same thing as saying 2dA. So we're going to go ahead and isolate a on its own by doing the opposite of what's happening to it. Currently it's being multiplied, and we need to go ahead and divide by what is being multiplied. So we're going to go ahead and divide by 2d. Do it on the other side as well. And 2d, this gets canceled out, that gets canceled out. We're going to rewrite our equation as vf squared minus vi squared over 2d is equal to acceleration. And now we see that a is on its own. We've got everything, so that is our answer. So vf squared minus vi squared over 2d. Okay, so now we're moving on to number 6, and we see an equation that we've seen before, not seen before, but something similar. If you remember, number 6 is set up the same way as number 1, 2, and so on. And by that, I mean you've got 3 parts, 1, 2, 3. And we've got 3 parts here as well. So we just happen to have multiple variables and a pi and so on. Now, again, this doesn't mean that you automatically start drawing that arrow. Don't make that mistake. Look at what you're solving for. In this case, it's r. R is not in the bottom. So you're not using the shortcut method here. You're using the full step. And by that, I mean you got to use the proper math version. So r is 2 pi r is currently being divided by capital T. So we're going to go ahead and try to isolate r. The way we do that is by multiplying by t over here and by t as well over here. That's our first step. Rewrite your equation. TB is equal to 2 pi r. And now 2 pi r is equal to TB. R is being multiplied by 2 pi. Do the opposite of it, which means divide by 2 pi. Do it on both sides. And 2 pi over here gets crossed out. This gets crossed out. Now we rewrite our equation as r is equal to TB over 2 pi. We successfully isolated r its own, and we are done with that problem. Again, remember, that step will only work, the arrows, the double-sided arrow only works if you are doing something where you're solving for the bottom variable. In this case, we were solving for r, which was on top, not down here, so we couldn't use that. All right, let's move on to a simpler one. Force is equal to mass times acceleration, or F equals ma. In this case, you're solving for a. M is being multiplied by a, so do the exact opposite of it. So divide by m. This crosses out, this crosses out. So you get a is equal to F over m. And we are done with that. Pretty simple. Again, just do the exact opposite of what you need to, isolate for the variable that you need. All right, number 8. Number 8 is set up in a similar way as number 6 and number 9 and 1 and 2 from the previous page. And by that, I mean, again, we've got a 3-part equation. Here's the first part, there's the second part, and there's the third part. And so that's one of the scenarios that it checks out. Then you look at what you're solving for, m, lowercase m. In this case, it's on top. So again, do not use the arrows. We're solving for this up here. So we're going to have to do the full step, or the full amount of steps. So we're going to go ahead and solve for m. currently is divided by r squared. We have to do the exact opposite, which is multiply by r squared on both sides. These cross out, and we rewrite our equation as f r squared, or you could have wrote r squared times f, doesn't matter, is equal to g capital M over lower and multiplied by lowercase m. All right, so now we're going to go ahead and isolate lowercase m on its own. It's currently being multiplied by g and m at the same time. So we're going to go ahead and divide by g and m at the same time as well. So capital G, capital M are both being divided here. 2 to one side, 2 to the other. This gets crossed out, this gets crossed out. We rewrite our equation as f r squared over capital G times m is equal to lowercase m. And we've isolated m on its own. This is our answer. So I'm just going to go ahead and put it nice and neatly over here. F r squared over g times m. All right, so now we're moving on to number 9. Again, number 9, similar way. It is 3 parts, 1, 2, 3. This time we check, and r is at the bottom. So yes, this is a scenario in which we can go ahead and use the arrows. Just keep in mind that it's r squared here, and you're solving for r, which means there's an additional step. So draw your 2 double-sided arrows, flip-flop them. You get r squared is equal to g times m over g. We've successfully flip-flopped. But we want r on its own, and currently we have r squared. So we still need to do one more additional step, which means take the square root of the whole thing. And now it's r is equal to square root of g m over g, the whole thing. So square root of g m over g. Pretty easy so far. And number 9. Quite often in physics, you're going to see equations where it's written as 1/2. Make life easier on yourself and rewrite 1/2 as 0.5 mv squared. So a lot of times when I'm starting an equation for physics and you'll see me writing, I'm not going to write as 1/2. I'm just going to go ahead and write it as, in this case, k is equal to 0.5 mv squared. It's neater, it's easier to punch in a calculator, but it also makes your life easier. And by that I mean, right now, everything is being multiplied. 0.5 times m times v squared. So everything's currently being multiplied. We're solving for v, which means we're going to go ahead and divide by 0.5 m to isolate v on its own. It's v squared right now. But the first step is to get rid of that. So divide by 0.5 m and divide by 0.5 m here as well. These cancel out. These cancel out. Rewrite your equation as k divided by 0.5 m is equal to v squared. Now we're not done yet because it's v that we're after, and we have to go and do take the square root of it. So take the square root of one side, take the square root of the other side, and when you rewrite your equation, it's v is equal to the square root of the whole k divided by 0.5 m. And that's our answer. We're going to go ahead and put up here equals square root of k divided by 0.5 m. Box your answer, and you are done. Okay, folks, there you have it. This was basically a review on algebraic expressions, manipulating equations. Again, most of these equations did not involve a number. We never solved for a numerical value. The only numbers that you saw were potentially the 1/2 or the 2 that might have been there occasionally. But the process of solving any algebraic equation is the same exact way. Follow the steps, do the exact opposite of what's being done to it, which you do one side, do to the other, and you will be manipulating equations to solve your answers. So hopefully this video has been helpful and you feel more confident in your skill set now to proceed with our physics course for the rest of the year. Again, please come back to this video as often as you need. that's that. Have a great day.